which is titled Constant Ratios in Right Triangles. We're going to be working on pages 17 through 19. If you're not turned there, go ahead and turn there. And we're going to be answering the question, what patterns can I use? We're going to read the math notes page on page 19 first, and then we'll come back to page 17. So flip over to page 19. Let me zoom in just a tad. Page 19 is our math notes, and it's titled Slope and Angle Notation. If you have a highlighter, you can highlight that. If not, go ahead and just circle it. The slope of a line is the ratio of the vertical distance and to the horizontal distance in a slope triangle formed by 2 points on a line. The vertical point part of the triangle is called the change in y, while the horizontal part of the triangle is called the change in x. Slope can be written as the change in y over the change in x. Slope indicates both how steep the line is and its direction, upward or downward, left to right. The Greek letter delta is often used in mathematics to describe change. Mathematicians sometimes use Greek letters as variables for angle measurements. The most common variable for an angle is the Greek letter theta, pronounced theta. Okay? Two other Greek letters commonly used include alpha and beta, pronounced beta. When a triangle is oriented like a slope triangle, such as the one in the diagram above, the angle the line makes with the horizontal side of the triangle is called a slope angle. Okay? So this little symbol right here is the theta. This is your change in y, and this is your change in x. Go ahead and flip back to page 17. And we're going to start with question 68. Question 68 is titled Patterns in Slope Triangles. In order to determine an angle, you need to investigate the relationship between the angles of the sides of a right triangle. You will start by studying slope triangles. Notice that one slope triangle has been drawn for you in the diagram below. Note, for the next several lessons, angle measures will be rounded to the nearest degree. Part A says, draw 3 new slope triangles on the line. Each should be different sizes. Label each triangle with as much information as you can, such as its horizontal and vertical lengths and its angle measures. I couldn't fit 3 more, so I put 2 more because one's already there. So the first one that they gave us had a run of 5 and a rise of 1 with an angle measure of 11. That one was in black. Then I drew one in blue. It had a run of 10 and a rise of 2. It's still going to have the same angle measure of 11. It's just double this one, right? You take 5 and you double it, you get 10. You take 1 and you double it, you get 2. Okay? Then I drew the triangle in orange, and it wouldn't fit over here, so I started it in the middle of the blue one. It has a run of 15, so a rise of 3, because 5 times 3 is 15, and 1 times 3 is 3. It also has an angle measure of 11 degrees. Okay? Part B says, explain why all of the slope triangles on this line must be similar. Because of something called angle-angle similarity, where we have 11 degrees, 11 degrees, 11 degrees, and this corner is going to give you 90 degrees, 90 degrees, and 90 degrees. So 2 of the 3 angles in each of those triangles are congruent, meaning they're similar by angle, angle. Any questions on part A or B? Okay. Part C says, since the triangles are similar, what does that tell you about all the slope ratios? From the first triangle to the second triangle, we multiplied by 2. And from the first triangle to the third triangle, we multiplied by 3. So all of the ratios are equal or the same. Okay? Part D says, confirm your conclusion by writing the slope ratio for each triangle as a fraction, such as the change in y over the change in x. We also call it delta y over delta x. Note, delta y represents the vertical change, or what we call the rise, while delta x represents the horizontal change, or what we call the run. Then change the slope ratio into decimal form and compare. Okay? So I did the first triangle, the one that they gave us in black. The rise is going up just 1 unit. So I put that in the numerator where the rise goes. And then in the denominator, I put the run. So from here to here, they already have it labeled for us as 5. To change that fraction into a decimal, you're simply going to take the numerator of 1, divide it by the denominator of 5, and it's going to give you the decimal 0.2. Okay? If you need help using your calculator, let me know. All right. Any questions on C or D? Okay. Let's look at question 69. Question 69 says, Tara thinks she sees a pattern in these slope triangles, so she decides to make some changes to investigate whether or not the pattern remains true. She asks, what if I draw a slope triangle on the line with a change in the y of 6? What would be the change in x of my triangle? Answer her question and explain how you figured it out. Okay? So, if we know that the change in y is 1 and the change in x is 5, but her new triangle is going to have a change in y of 6, we want to find the change in x. So we're going to put our variable there. This is called our proportion. In order to solve a proportion, we do the cross product. So we multiply 1 times x, which is 1x, and we multiply 5 times 6, which is 30. So we get x equals 30. Okay? Proportion, cross product, solve. Okay? Part B says, what if the change in x is 40? Tara wonders. Then what is the change in y? So now we're going to fill in the denominator and put our variable in the numerator. But we follow the same basic pattern. You set up the proportion equal to 1/5. You do the cross product, so 5 times x is 5x. Set that equal to 1 times 40, which is going to give you 40. Divide both sides by 5, and you're going to get x equals 8. Tara wonders, what if I draw a slope triangle on a different line? Can I still use the same ratio to calculate a missing change in x or change in y value? Discuss this question with your team and explain to Tara what she could expect. Okay? The change in y over the change in the x will be different for different slants. So it just depends how your line is slanted. This one right here is slanted just slightly, but if you had a line that was super steep or even went down instead of up, you're going to have a different ratio. Okay? Any questions on page 17? Anybody still writing? All right, flip over to the top of page 18. At the top of page 18, we're going to look at problem 70, which says changing lines. It says protractors are needed, but they're, I'm just going to show you how to use it. Okay, so in part C of problem 69, Tara asks, what if I draw my triangle on a different line? With your team, investigate what will happen to the slope ratio and the slope angle when the line is different. Use the grids provided to graph the lines described below. Use the graphs and your answers to the questions below to respond to Tara's question. On graph A, graph the line y equals 2/5 x. What is the slope ratio for this line? They actually give us the slope ratio. It's right in the equation. It's 2 over 5. 2 over 5. That means we're going to go up 2 over 5. Okay? What does the slope angle appear to be? And does this information about this line support or change your conclusion from part C or problem 69? Explain. So depending on which protractor you're given, they are all used slightly differently. So you might get a protractor that looks like this, okay? And you can set the center or the middle right at the vertex. On this one, it has a Y, and then you're going to match up the line over there, and it's going to go through approximately, and we're rounding to the nearest whole number, 22 degrees, okay? You might get a protractor that looks like this. Same thing. You're going to line up your vertex to go through that little dot right there. You're going to see that over here, it's just slightly larger than 20, roughly 22, okay? You could even get a protractor that looks like this. You're going to line up the center of that little circle right at the vertex. And the red numbers are inside, so that's 10, 20, 21, 22 approximately. Okay? So that's how you use a protractor. Any questions on part A? Okay. Part B says on graph B, you're going to create angle QPR so that it measures 18 degrees. First, place your protractor so that point P is the vertex. Then find 18 degrees and mark and label a new point R. Draw the ray to form triangle QPR. What is the approximate slope ratio of this line? Okay? So they wanted you to start at P, which is right there. If you set the center of the circle on the protractor, you're going to measure out 18 degrees, and you put a point, and then you draw your line up to point R, and that's going to give you approximately 18 degrees. From P to R, you're going to have a rise of 4 units. So from this line up to R is 1, 2, 3, 4. And your run is going to be this direction, 13 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's going to be your slope ratio of 4 to 13. And your slope angle is going to be approximately 18 degrees. Any questions on part B? Okay, one more. Part C, as in cat, says, graph the line y equals x plus 4 on graph C. Draw a slope triangle and label its horizontal and vertical lengths. What is